All right, so for this first application, I drew some pictures already. So we have a tree that's 9 feet tall and casts a shadow 5 feet long. So I drew the sun there so you can imagine how that shadow is created. And then at the same time of day, so that's going to be key information, a flagpole that is an unknown height casts a shadow that's 15 feet long. So before we go ahead and set up a proportion, so our brain will think, well, it's proportion because we're in a lesson about proportions and similar triangles. We want to make sure that our triangles are similar and verify that before we know we're allowed to set up that proportion. So why this statement here is important is that tells us that the sun is hitting each of these objects at the same angle. So that tells me that these angles here are going to be the same. And then now these two triangles that were created by those different lengths have two congruent angles. So now we are able to make the claim that the triangles are similar by that angle. Similarity theorem. Similar. And then having justified that and stated they're similar, we can now set up proportions, or a proportion, so like 9 and x, 5 to 15. Oops. So 9 over x equals 5 over 15. And then just do our solving steps. So cross multiply 9 times 15 equals 5 times x. And then 9 times 15 is 135 equals 5x. And then we divide to get x is 27 feet. So that's the flagpole height. All right, and then we could plug that back in here and then verify that those are proportional. And then our second application, so kind of a similar idea. We have two triangles formed. So this picture represents the information in this problem here. It's already drawn out for us. But before we can jump ahead and say, well, I can set up a proportion for these two triangles, we need to verify that they are similar triangles so that I know that those sides are proportional. So in these pictures, we can put those 90s in, so that would be one common angle. And then a rule in physics, or a law in physics that relates to geometry, is that if I have anything being like reflected, so like light, or like in this case his line of vision, the angle that we enter that reflection, it bounces back at the same angle. And then by like geometry properties, we can say like if these angles are equal, we can use like complementary angles to say those angles are equal. So in this picture, that this like reflection here tells us that these angles are congruent. So now we have two angles that are congruent. So these are similar by angle again. And then that like similarity check. So now we can for sure say that our corresponding side lengths are proportional, and we can set up a proportion. So we can do 5.5 over x for those green ones, and then 4 over 24, and then cross multiply. So 24 times 5.5 equals 4x, and if we multiply those, we get 132. And then dividing by 4 leaves us with 33 feet, and that is the height of the tree. And then again, we can plug that back in and verify the proportionality there.